Welcome to School Page Key Concepts. Determination of empirical formula explained. Now let us learn how mass percentage data can be used to find out the empirical formula of any given compound. The first step to identify the empirical formula using mass percentage data is to assume 100 grams of a compound and then convert the mass percentage of elements into grams. Then using this data, calculate the molar ratios of each element in the compound and then divide the values by the lowest mole ratio. Using the data obtained, assign the empirical formula to the compound. So let us take an example and understand these steps better. We have to determine the empirical formula of a compound which has 40% of carbon, 6.71% of hydrogen and 53.33% of oxygen. So the first step is to assume 100 grams of compound and convert the mass percentage of elements into grams. So it is 40% of carbon. So I assume that for every 100 grams, 40 grams of carbon is present. In the same way, hydrogen is 6.71%. So for every 100 grams I have 6.71 grams of hydrogen. In the same way, I do have 53.33% of oxygen. So for every 100 grams I have 53.33 grams of oxygen. So in 100 grams sample I have 40 grams of carbon plus 6.71 grams of hydrogen and 53.33 grams of oxygen. Now that we have converted mass percentage of elements into grams, let us move on to the second step. To calculate the molar ratios of these elements in the compound. To calculate the molar ratios, we do consider the atomic mass of elements and recall the rule that 1 mole of an element will always be equal to its gram atomic mass. So, for carbon, 1 mole of carbon will be 12 grams. We have 40 grams of carbon according to the previous conversion. So, how many moles will be the 40 grams of carbon? This is what we have to calculate. So, according to the calculation, we get 1 into 40 by 12. So, that will come up to 3.33 moles. In the same way, for hydrogen, 1 mole of hydrogen is 1 gram. 6.71 grams of hydrogen will be 6.71 moles. For oxygen, it is the same and 53.33 grams of oxygen will be 3.33 moles. Now we have molar ratio, that is carbon, hydrogen and oxygen as 3.33, 6.71 and 3.33. The next step is to divide the values by lowest mole ratio. So the lowest mole ratio among the three values is 3.33. So let us divide the mole ratios of the respective elements by the lowest mole ratio, that is 3.33. So we get the answer for carbon as 1, for hydrogen as 2.01 and for oxygen as 1. So we have got the values as 1, 2.01 and 1. Keep that in mind. And the last step, using the data in the previous step, we assign the empirical formula to the compound. So the mole ratios of carbon, hydrogen and oxygen was found to be 1:2:1. So when we assign these numbers to the carbon, hydrogen and oxygen, we get the empirical formula as CH2O. As you can see, the empirical formula of a compound is the simplest whole number ratio of atoms of each element in a compound. But the analysis will not stop here, because it's only the empirical formula which has been found out. The next step is to calculate or determine the molecular formula of a compound. Remember, mass percentage data is used to determine the empirical formula only when the compound is unknown, and hence it is not clear what the molecular formula of the compound is. So the first step is to determine the empirical formula and then go for the molecular formula. Thank you for watching. For more videos, visit our website schoolpage.me.